simple harmonic oscillators. All right? And in this case, harmonic does not mean harmony. Okay? It means that you've got, as an example, a pendulum, something that moves back and forth over the same sort of period over and over again, like this metronome here. Okay? And that comes into play in a lot of different cases in physics. And one of them is the pendulum. And that's what we're going to talk about today. Pendulums. This is not really a pendulum, but it has some of the same properties. You can adjust how long it takes to swing back and forth by moving it around. Now it swings slower when this arm is longer. And if we shorten it again, it swings faster. That's very similar to what happens with pendulums. Let's go take a look at some pendulums. So now if we take a bowling ball and put it on a long cable, we've got a long pendulum. All right? It should have a long period because it's pretty long. But the thing about pendulums, right, is they only contain as much energy as you put into them. Right? So if I let a pendulum go, it's going to go away from me and come back and not come back any further than when I let it go. So if I back all the way up here and let go of the ball, it'll always come back to the same spot. So if I want to play with fire a little bit here and show my belief in physics, if I take the ball and put it right up to my nose and let go, it'll come back, and it shouldn't come back any closer, like that. So let's get a close-up of that. Now, a simple pendulum is typically a heavy mass attached to a string or a wire of something. You could think of a rod as a pendulum, but it's simpler to use a heavy mass because then you don't have to, you just kind of ignore the mass of the string. And a pendulum has a certain time it takes to swing back and forth. We call it its period. Okay? And the time it takes a pendulum to swing only depends on how long the pendulum is, how long the wire is, okay? And what's the gravity where you're at. So the length of time it takes us to swing will change if we go to a different planet. All right? But since that's kind of hard to do, we don't have the budget for that, we can just change the length. So here we go. Let's see how long it takes to swing. We go 1, 2, 3, 4 kind of thing. That's how fast. If I shorten the pendulum, whoa, 1, 2, 3, 4, 5. Okay, so it's a little bit faster there, timing it. All right, so the shorter the pendulum, the faster it swings. As I get it up even higher, it swings even faster. All right? So that's a basic concept of pendulum. Now there's some interesting things about the conservation of energy in a pendulum. If I pull the pendulum back a certain distance, it'll swing down and gain kinetic energy, energy of movement, and then go back up and get potential energy. And so if I let go, it always swings back to the same spot. It'll never swing back higher than where I let it go, because otherwise it would have gained energy. So let's see that in a better demonstration. So now let's have some fun with the pendulum. This weight is much lighter than this weight. All right, so it's pulling down on the rope here much less than it would take to pull up on this to lift it off the ground. But yet I can get this weight to lift that one up into the air. Watch. Just amazing! The paper fell on the ground. Isn't that amazing? Amazing science. Okay, so why is that happening? Well, it's our old friend circular motion. All right, remember, circular motion says if you go in a circle, you have to be pulled towards the center of that circle in order to go in a circle. You can't go in a circle unless you're pulled to the middle. Well, when this mass here is going in a circle, so it's being pulled where? To the middle of the circle. All right, centripetal force is pulling it to the middle. So when it hits the bottom, not only is gravity pulling down, and therefore the string is pulling back up against gravity, but the string is also pulling up using the centripetal force, right? The same amount the centripetal force is. And so you got the pulling up of the centripetal force, and you have the pulling up, the fight against gravity, and those two together are enough to lift the weight off the ground.